Oh, can you hear me? Yeah. I'm joining you from France, so hopefully everything's going to work okay, but do raise your hands if you can't hear me, or if I keep cutting out. I'm a mechanical engineer. I'm also a certified Passivhaus designer. I got most of my experience working for ARUP as a consultant for 20 years. And then a couple of years ago, I set up Humblebee, and I now collaborate with the Carbon Co-op and on their people-powered retrofit. So I'm going to start this session off. It'll be a little bit different, possibly from the last few, in that it's a little bit more theory to start with. And I'll give you a bit of context for why we look at retrofit and the whole house approach and how the heat pump actually fits into that. So I will. So why do we do a whole house upgrade and retrofit? I'm hoping most of you are coming on to learn how to reduce your carbon footprints, but there are all sorts of issues that will interact, including costs and comfort and well-being. So we look at the home as a system, and your home will have different volume and areas, all through which you're losing heat or gaining heat, and that's what we call the fabric, is the envelope, and that's what determines your heat loss from the building. So fabric heat loss is one aspect of the system. Another aspect is ventilation, and that could be through natural means, or it could be pulled through mechanically through extract fans through your house. Generally, when we talk about ventilation, we mean intended ventilation, but there's also unintended ventilation called infiltration, air leaking in from outside. Both of these aspects will bring in air from outside, and therefore it's cold in the winter, and that's something that you need to heat up, and therefore impacts on your heating systems. Modern buildings will have controlled ventilation, and the reason we prefer controlled ventilation is because we know where it's coming from, where it's going, and we can recover heat from it if we can. So with a retrofit, we try and do as much of that as possible as well. So all these represent losses, and you would need to balance those losses with your heating systems, and that's what your boiler does. You burn fuel, it heats up water, and that water radiates through your radiator system into your spaces, and then that heat that you put in is then lost through the fabric, and you're always trying to maintain an equilibrium through that system. There are other heat sources, so your boiler is not doing all the work necessarily. You have lights, you have appliances, and you've also got people, and it's the people that you're trying to keep comfortable, obviously, as well as keeping your fabric intact and keeping mold away and those kinds of things. But all these systems interact, and sometimes those ways aren't easy to understand, and quite complex in their interactions. So this is for just looking at sort of what we need to achieve in terms of reducing our space heating demands, and this is so we can meet some of our carbon targets. For one particular house type, the UK average could be, say, 140 kilowatt hours per square metre. And the building regs in the 2000s was looking at a fabric efficiency of about 100 kilowatt hours per square metre per year, and each decade has brought its own tightening of the building regs. So that's come down to 65, and then we've got these low energy building standards. So the AECB standard is actually a 70% reduction from current. So that goalpost keeps moving. But if you took 140 as your average for that house type, then you'd be aiming for 40 kilowatt hours. EnerPHit is the Passivhaus standard for retrofit. It has got a set target, which is 25 kilowatt hours per square metre, but sometimes you can get it through by the component method, and you might be more in a range. Whereas a new built passive house would be right down to 15 kilowatt hours, and that difference is generally the air tightness that you can achieve. So this just shows you the different house types that might have different targets to get the same level of efficiency in order to meet Greater Manchester's net zero target, for example. And that comes from a 2009 report, which was defining fabric energy efficiency. So with the Carbon Co-op and also with my own work, we look at the house and we take a fabric first approach. So we look at reducing all the space heating demands by acting on insulation, air tightness and windows before we look at the systems that we apply, and in that we use the more energy efficient ones, and then you can top that up with your own renewable energy, or whoever you get your energy from. There are plenty of co-benefits, obviously. If you insulate your house better, you have a much more stable environment, and the surfaces around you aren't at different temperatures, which also contribute to discomfort. But it's always good to have a plan. So what does that mean in the context of a heat pump course? Well, let's look at a traditional boiler installation. So your boilers will tend to be about 20 kilowatts or more, and that's to overcome some typical heat losses from the dwelling, as well as providing your hot water. If it's a combi, you're trying to raise the hot water, the incoming hot water, from about 10 degrees to 45 instantly. So so that's a lot of power input into that hot water, which is why some of your boilers are rated higher, and that will depend on the size of your household. A radiator system will usually have operating temperatures of around 60 to 80, and you might set them differently to what they were originally commissioned at. You will have adapted your system to the way you like to have your house, but the basis of your radiator sizes are based on those higher temperatures, 60 to 80. And for a 20-degree internal temperature, you're looking at between 150 and 250 kilowatt hours per square metre per annum. Typically, depends on your type of dwelling. With a heat pump installation, in theory, you could deliver the same amount of heat, but we're talking about a much more complex piece of machinery, which has different processes working together, and each component will have different efficiencies depending on how it's set up. So And then the other, so I think we've talked about COP in the past. I'll just refresh your memories. The amounts of heat energy that you get out compared with the amount of electricity that you use as a ratio is your COP. So if you get 4 kilowatts delivered as heat, and you put in 1 kilowatt of electricity to get that heat out, then your COP is 4. So if electricity is costing you about 2.5 to 3 times your gas, then you might be more inclined to pay for your heat pump operation if you can manage to average out that kind of ratio as a COP. The hot water system will be a key, so the design of that will be a key component of keeping the size of the heat pump down, and that's a whole lesson in itself, but we've talked about them in previous sessions, and we'll definitely cover them in session 5. But your operating temperatures are a lot lower than your boiler, and that means your radiator will need to be larger or be fan assisted to get the same output. So if you approach it in the way that we do, which is significantly reducing your heat losses from the home, you can keep your machine size down as well. And I am talking to you from my parents' house, which is a nice stone farmhouse in France, 60 centimeters thick stone walls, but and at the bottom of the garden is a 2-bed bungalow which was built about a decade ago, highly insulated, not passive house by any means, but energy efficient with underfloor heating. So my dad installed, commissioned the house on the right with a split system heat pump. So that's an 8 kilowatt external unit with the corresponding internal unit, whereas the stone farmhouse has a much more substantial installation. That's a 16 kilowatt monoblock with a hydronic unit inside, so that also does the hot water. That's got the hot water cylinder, and there's a buffer tank to help smooth it out. So if we're looking at the sort of aspirational targets, then we're looking at EnerPHit, and that has a target of 25 kilowatt hours per square metre per year, which could be up to a tenth of what you're looking at the moment. Generally, it's about 30% of a typical house, and then a low energy house, or the AECB standard, is 25 to 45 kilowatt hours per square metre per year mark. Now, if you were to start with a blank page, you'd be looking at these principles of Passivhaus, which is form, so that's the amount of heat loss area that you have for the heated volume compared with the surface area that you lose your heat from. If you remember that first diagram at the start. Orientation, so you try and orientate your building so that you get the most benefit from the sun, minimize the windows on the north because you don't get any from there. Then you've got insulation and avoiding thermal bridges, air tightness to avoid cold air just coming in an uncontrolled way, and then you'd have controlled ventilation, so you'd bring in the amount of air that makes it comfortable, allows people to get rid of indoor air pollutants, reduces the the likelihood of mold, but you recover the heat from the system by exchanging it through a mechanical ventilation with heat recovery unit, MVHR. And one thing we do absolutely have to take care of are the solar gains in the summer. Make sure it's comfortable in the summer as well. So that means shading generally and deep reveals. So that's just going through the sort of technical bits. In terms of insulation, we're also talking about triple glazing. So a good double glazed unit would have a U value of 1.24 watts per square metre, and we're looking at reducing that right the way down. And then you would need to look at the overheating as well. And what does that mean in retrofit? Well, obviously you're stuck with the building you have, so there's no changing form unless you're doing a significant extension, for example, and there's no changing the orientation necessarily. So things that you can act on, albeit quite tricky, are insulation and your windows, the air tightness, and your ventilation. Air tightness, with EnerPHit we aim for 1 air change per hour. So with a passive house that would even be lower than that, would be 0.6. And the idea is that you have a continuous barrier as much as possible to any air penetrating the building. And to once you do that, you will need background ventilation, and although natural ventilation is possible, it's not always that controlled, and although you will still need some natural ventilation for controlling overheating. So if you have the space and the budget, then we definitely recommend going for MVHR. This means you can have your minimum air coming in at a reasonable temperature. It's all filtered, so no pollens or pollution coming into the house. Comes in and exchanges heat with the internal air that's going out through your bathrooms and kitchens. So this is basically the end of what I was going to say. When we were chatting and planning this session, I think it was Polly that said perfect is the enemy of good. So I looked it up, and quite fittingly it's by Voltaire, and he was quoting a wise Italian. So with my Italian and French heritage, I thought that's pretty cool, I'll nick that. And then so I guess Liam will go through some of the practicalities of doing retrofit, and it's not always easy, and you won't always have the budget to do the maximum. So I think the key message is aim to do as much as you can afford to do, and do the things that you can do well. So that's my part of the presentation. So if I stop sharing, then Liam can carry on.
Yeah, cool. Yeah, thanks for that. That was rather more technical than mine's going to be.
That's what I'm here for.
Yeah. So yeah, as Florence said, mine's a bit more. Well, it's more about the practicalities of doing retrofit to this scale. And the ideas behind the fabric efficiency that you'll be looking at hoping to achieve. I'm sorry, I'm just trying to make it on proper full screen. There we go. Okay, right. So yeah, hello. I've got this is so for, like I say, for the planning for low carbon heating systems. But I'd be non-specific, even though this is about air source heat pumps. So just a little bit about my background. I'm the retrofit advisor and manager on the people powered retrofit for Carbon Co-op. I've worked in energy efficient construction for over 8 years now, on new build and retrofit, so big jobs and small. More of my interest has always laid in retrofit, 'cause it's more like a puzzle than a new build is. So all of my experience has been on energy efficient builds. I'm the guy who trained me in the first place referred to me as a native in it, because I've never seen the other side of construction. I started off as a labourer, moved on to being a main contractor, consultant, and such like. I'm a trustee of the Association for Environment Conscious Building, which is the AECB. Just a little side thing, there's a lot of interesting resources on the AECB website at the moment for this sort of thing, and it's free to look at them, for the short term anyway. It started in lockdown and it's not been stopped yet. But yes, so thanks to all of the above, I've become an incredibly tedious man in most situations, especially if I get started talking on air tightness and insulation. So these are a couple of jobs that I worked on. This is in Longsight. It's called Ernley Close. This was a deep retrofit to the full EnerPHit standard that Florence was talking about earlier. So I had a combination of internal wall insulation, external wall insulation. It didn't have any air source heat pumps or anything, but it did have a full mechanical ventilation system. This is where I'm currently speaking to you from, which I've ended up living in because my company did the build on it. This is a deep retrofit which does have an air source heat pump, a couple of air source heat pumps, which I'll come on to discussing in a little bit. Then this is an EnerPHit project in Manchester, which again didn't have an air source heat pump. It had solar PV and different type, what's it, a Sunny Boy inverter, which runs off the PV to generate more hot water. And this was the first project that my old company undertook, which was a Victorian end terrace, which went to full Passivhaus standard and had all manner of technology installed in it. The really interesting project to have done, particularly because down this side here was a small stream, which meant that fitting the scaffolding was an absolute nightmare. So let's come on to the next bit. Why retrofit in the first place? Well, the main reasons I'm sure we all agree would be to increase energy efficiency, to improve resilience. This means against, say, if you've got gas at the moment, which is a particularly good point because an air source heat pump is really, it costs 3 times as much per kilowatt hour to run an air source heat pump, just by sheer dint of the fact that that's how much more money as an average electricity costs over gas. But gas prices are going to change over the years, and hopefully electricity prices are going to reduce as we bring more renewable energies on. So yeah, it should hopefully make life easier for us in that. So it's improving resilience against, as I say, a fluctuating energy market, against some of the effects of climate change. I've not put all of the effects of climate change because it doesn't matter how energy efficient you make your house, it's not going to stop it from flooding if you live on a floodplain. Also, an important thing about retrofit that doesn't often get thought about in the early planning stages is to carry out maintenance on your property. Because if you, for example, if you want external wall insulation, if your pointing's absolutely shot, then you're going to get thermal bypass. It's just for basic renovation to your house. If you put internal wall insulation on and the external brickwork is in poor condition, then that will allow additional moisture into your house, which can cause problems with condensation and moisture behind the internal wall insulation. Another important element of it is to improve comfort. For example, where I live now is, I used to live in an ex-council estate house in Lancaster, an incredibly well-built house, but it was absolutely freezing. It had a minimal cavity, everything was concrete slab that projected outdoors, and it was really cold. Now I've moved into this house, which has got an air source heat pump, but without solar panels, which does make a difference because solar panels and air source heat pumps work really well in conjunction to each other. Last winter, I wouldn't say that I really saved any money versus living in my old house, but we were a lot warmer. I didn't crack open the hot water bottle bag. I didn't have to sit in front of a gas fire sort of 3 inches away from it, gently cooking my back and getting a smell of bacon. So that's an important thing to remember, to think about when you're looking at retrofit. Help the environment. Obviously, the less energy we use, the better for the environment. The more that we can move away from gas and onto hopefully renewable energy. There's also the whole sideline of the extra nuclear power plants that we're probably going to have in the UK, which I'm not going to make a judgment on. You can all draw your own conclusions. And one of the other aspects is to improve health, because living in a cold, damp house causes terrible problems with asthma being a particularly good example of it. Hay fever can be worse if you live in an unventilated house. And having a decent ventilation system installed just helps that airflow and makes your house a much healthier environment to be in. Obviously, fit a lower carbon heating system. So we're going to talk about that a lot, so I don't think there's any need to expand on it on this point. This is a picture of the EnerPHit house in Manchester that I was telling you about before. This is the householder, John Grayson, talking to my ex-colleague about the build process, and this is the external wall insulation which went on, which is a EPS system with a permarock render on it. So, what do people think about when planning a retrofit project? Like, the first thing that people tend to think about is the technical complexity and the knowledge needed. It can be quite easy for people to be put off retrofit at this very early stage just by thinking how complicated it appears. Also, making key decisions at important times. It's thinking about the process, what gets you to this point. In regard to an air source heat pump, a lot of people sort of initially think that they want a low carbon heating system and work back from that point. It's something that I'm going to drum in a few times throughout this presentation, but there is absolutely no point in fitting an air source heat pump if your house is cold and drafty, or if it's damp, or is in a poor state of repair. It's something which comes along, whether it's talking about the retrofit build or whether it's finding specialists, particularly in regard to an air source heat pump or solar PV, is finding contractors. Actually finding contractors who you feel that you can trust, that you get along with, who appear knowledgeable. That's a universal, even if you're just having a standard extension put in. The worry of finding someone who is decent. The same again with trust. There's worries about risk and quality. Someone might seem good and then cause problems. This goes across the board for specialists. Might appear that they know what they're talking about, and it comes down to it, and there's issues. As an example, the house that I'm in now has had an air source heat pump fitted. The contractor who fitted that air source heat pump, out of interviews with 6 different people and speaking as a builder myself, with no knowledge at the time of air source heat pumps, they seemed the best ones. They seemed the most knowledgeable. However, when it came to them getting on site, it was subcontractors who did the work. The wrong bore pipes were fitted. So the bore is for a standard gas boiler, which is, I should have checked this out before I actually started. I think it's 15 mil pipes for a boiler, which is what ours got. And I think it's 30 millimeters for an air source heat pump. But ours has got 15 mil ones, which means that the balancing can't be done correctly. The water doesn't flow around the system correctly. So our air source heat pump is not working as efficiently as it should be. So yeah, that's something to consider. Planning issues, particularly in regard to an air source heat pump or external wall insulation. If you're in a conservation area, you may have a battle on your hands getting through. It's not to say that you won't be able to, but it's something to consider at the very early stages. And then finally on this, cost is a big thing about it, because an air source heat pump is not a cheap item to fit. But if you're on a smaller budget, maybe you can't afford for a whole house retrofit or for decent or longer term measures to be done, then it might not be worth fitting an air source heat pump as part of that work. it might be better to improve the insulation value of your house, get your thermal values up, increase the air tightness, improve ventilation, do general structural repairs, and then save the money for getting the air source heat pump in the next tranche of work. So, what consideration needs to be made for an air source heat pump? As I said on the previous slide, fabric first, there isn't any point in fitting an air source heat pump in an uninsulated home. An air source heat pump will be very, very expensive to run in a cold house. It will have to be oversized. And then if you do carry on with retrofit works in future, then you will just end up with an enormously oversized air source heat pump for no good reason. It won't mean that it'll necessarily run at a higher rate all the time. It will just be a waste of money in the sheer material cost of buying the air source heat pump. Another thing to consider is the position of the unit. Quite a few people will have not very much space in the back garden. Maybe people want it down an alleyway. There's not very much room. It's just something to consider at the early stage. At risk of repetition, finding contractors. There is a question in the Q&A about finding contractors, and in short, there isn't an easy answer to it. There are people who are increasingly experienced at it. Ken Bone being a case in point, but it's an emerging industry. It's not there yet, like for just being able to go in the yellow pages and find somebody. Again, worries about risk and quality. This is just a constant which is happening in retrofit across the board, because it's again an emerging industry where everyone is still finding their feet. There are knowledgeable people, but the difficulty in finding those people might be more difficult than just finding a standard builder. And then planning issues and cost. The main reason I put them is because it's just to hammer home that there's a big crossover between air source heat pumps and wider retrofit. So this is a shameless plug for people powered retrofit, and why it might be helpful to some people who are here today in planning for their retrofit, planning for their air source heat pumps. So why people powered? The UK has struggled developing a sustainable business model for retrofit services. There's the new government announcement which has come out, which is still not there on deep information, but a top-down approach has time and again hasn't really worked when it's come to retrofit. For example, Green Deal, and there's some pictures of a place in Preston that I'm going to show shortly, has demonstrated that this doesn't really work on sharing the knowledge. Retrofit and low carbon heating are both relatively new. Knowledge and experience, they lie with the early adopters. Most people who are sharing the knowledge, who have built this knowledge, are people who have just gone for it and are interested in how this technology will work, how the insulation will work. A few of us who fitted insulation in certain places have, in hindsight, made terrible mistakes in figuring out how it worked. Fortunately, those mistakes have been made now. Timber suspended floors being a perfect point of it. I've done it on my own. I did it on my own home, where I had issues where I caused rot in my floor because I'd insulated the floor in the wrong way and hadn't thought about how the ventilation would work. So yeah, hopefully most of those mistakes have been made and people are learning. We're all sharing information. This is the place in Preston that I was talking about, which is Fishwick. This was done under the Energy Company Obligation Scheme. And I mean, I don't have to demonstrate, but this area here, all of the flashing is completely the wrong way round. And it's just, all that did was push water down onto the brickwork, bypassing the external wall insulation, and caused terrible damp problems in people's houses. Rather than changing the guttering, for example, they do a cutout and have left a big cold bridge in that wall. So yeah, the UK, we have struggled to develop a sustainable business model for owner-occupier retrofit services. There's a lot of reasons for that. There's as a builder, there's not that much profit in retrofit. To go back to trust, that's the big issue on both sides. Householders have had their fingers burnt by builders. Builders have had their fingers burnt by householders. And because it's something new, everyone needs to work together to think about that. So the top-down approach is to fail to convince private householders or achieve high-quality works. Again, with the Green Deal, not many people took advantage of the scheme, probably because the interest rates were so high, but it didn't trigger retrofit in the way that people had hoped. So the people-powered approach focuses on enabling householders to work towards a deep or whole house retrofit. That doesn't mean that it has to be done all in one go. That means that you're thinking about the works in a whole house manner. To go back to what we're saying about fitting an air source heat pump in a drafty, uninsulated home, it's thinking about the process. So it's important to make sure that you've got the insulation in at the right times. Say, for example, you might want new windows, but you can only afford the new windows. It might be better to put that money into, say, underfloor insulation and wait until you can afford the external wall insulation and do those two jobs at the same time to make sure that things aren't being done at different levels. To go on to the next point, as I said, past programmes they've made progress in delivering the low-hanging fruit. Lots of people have had loft insulation, lots of people have had cavity wall insulation, but it hasn't done what we need to reach the carbon reductions that we need, that the world needs. So a bottom-up approach, which is the people-powered view, can build on assets that already exist at a neighbourhood scale. This is what I mean, the knowledge share. What we're doing now, all sitting down together in our homes, and we're listening to, well, hopefully useful advice and information. And hopefully in the Q&A, people are sharing that information. We're sharing local knowledge, building local relationships and quality workforce skills. If somebody's coming from 3 hours away who you're never going to see again, what drive have they got to do a good job? It's not going to affect them. Like, they might be tired from the commute, for example. But building local supply chain networks, including authority and community capital, which means, again, sort of a collective way of coming together, using that money in a sensible way. Hopefully, the economies of scale. If a whole street could have their houses retrofitted, have an air source heat pump, that would really bring down the cost for individual householders. The final important thing about a bottom-up approach is impartiality, because there are salespeople in air source heat pumps exactly the same way that there are double glazing people whose individual company names don't need mentioning. But maybe you can't trust a salesperson. They want to sell you a product. They don't have your interests at heart necessarily. And a people-powered approach can bring that independence to the project and hopefully help you think in a whole house way and get what you want for your money. So to move on to that and get off my soapbox about double glazing salesmen and such like, I'll move on to the basic retrofit principles, which are reducing damp, condensation and mold. This on the left-hand side is in a loft space, and that's because there was a bathroom underneath it and the plasterboard had all cracked in the corner and they had no ventilation system within that bathroom. Didn't open the windows after having a shower, and so all the moisture just gently seeped up onto the sarking board under the roof tiles and has caused quite significant condensation and mold damage. This on the right hand side is an internal wall insulation onto OSB, an American timber frame system, and the membrane had been put in the wrong position. So rather than it breathing, it was trapping the moisture within the timber buildup, and it had completely rotted that elevation of the house because the interplay between internal and external, where the airtight layer needs to go in relation to the insulation layer, hadn't been considered. One of the main important things, as I was saying, is reducing damp, condensation and mold. This is the kind of condensation that we've all seen on our windows. It's just one of those this is a stock image that I don't think anyone is capable of talking about condensation without using. So there's insulation in a floor, which is, again, a really important thing when you're coming to fit an air source heat pump, is thinking about the whole, as Florence was saying before, thinking about the whole envelope of the house and making sure that that's sealed up and that you've got no heat loss through any elements within it. So on the left-hand side, this is a classic build-up for putting a concrete slab. This actually had underfloor heating in it as well, which is why it's so low down. And the insulation around the perimeter here is to make sure that it will tie into any internal wall insulation that you've got, and make sure that you've got no cold coming up the walls and getting into the concrete layer. On the right hand side, this is a jute insulation going into a new suspended floor over bare earth. So this has had quite a system of cavity trays put in to stop any wind wash or any moisture getting into the insulation from the underside. Here we've got some roof insulation, two different types. So you've got the rigid insulation and earth wall style classic loft insulation. That's two ways of insulating at the rafter level. It's important to leave a ventilation gap to make sure that you don't rot the joists and the rafters if you are going in this way. I haven't included a picture of traditional loft insulation because I'm sure we all know what standard loft insulation looks like. So this is two types of wall insulation: internal wall insulation and external wall insulation. This internal wall insulation on the left hand side is wood fibre, which is bonded to the wall to try and minimize thermal bypass. So it's actually stuck to the wall. If you imagine how you do tiling with two adhesives, one on the back of the insulation, one onto the wall, and then it's stuck on. And then this is rendered over with a breathable render, and it's good because it allows moisture to travel through it in both directions, so hopefully isn't trapping damp in the wall. This on the right hand side is not breathable. It's the extruded polystyrene insulation. Is one of the cheaper ways of doing external wall insulation, good thermal value. And these two things here that you can see are the intake and extract for the mechanical ventilation system. And further on the retrofit principles is air tightness. As Florence was saying, is a really important thing to get right when tied in with ventilation, because it stops any unwanted cold drafts coming in through your house and causing drafts, basically. So this on the top side is what's called a parge coat of plaster, just to seal in those tapes, and then you over plaster that, and it's just to make sure that there's no gaps between the tape and the existing wall before you come to plaster it over. This particular membrane is an intelligent membrane and allows vapor to travel through it one way, so it isn't trapping moisture in. On the right hand side, this is sealing a concrete slab to the wall. It was, in this case, it was presumed to be a solid raft slab, meaning that there would be no gaps. And in air testing, it turned out that that wasn't the case. So we had to go along sealing all of the perimeters up, and it made a significant difference in the air test. So ventilation. This is, I like this picture. It's a really good example of understanding how moisture can be retained in the house if you don't have a decent ventilation system. So if you make your house completely airtight, all the moisture from your cooking, from your washing, from just being a human and walking around your house and breathing will get trapped in there, and all that moisture will build up and has nowhere to go. Yeah, this is a really common thing that you see when people are preparing for energy efficiency and trying to make their house warmer. This is a low-level ventilation brick to ventilate under a floor. If you're doing underfloor ventilation and it's timber suspended with a gap beneath it, that needs an absolute howling gale going beneath it. If your floor build-up with the insulation is done correctly, that's not cold air that's going to get in your house. That's cold air that's air that's stopping rot from happening. If you seal something up in this way, you are trapping moisture. So as I say, it's really common to see things like that, but any lack of ventilation does lead to internal moisture and mold growth. It's really, really important to consider this in your kitchen and your bathroom. Really, like a well thought out ventilation strategy is important in any house and in all rooms, but particularly in your kitchen and in your bathroom. As I said on the last slide, timber suspended floors need ventilation from beneath or they will rot. It's not they might rot, they will rot. It's also, ventilation is needed for the internal air quality. I know we're talking about air source heat pumps, but particularly if you've got an old boiler, you know, that's the buildup of CO2 emissions will cause problems. Also, one little aside is to make sure that open vents are rodent proof. No one wants rats living under their floor. This is just a basic image of how a ventilation system is meant to work. Florence had a very similar one and explained it in far more detail than I would, so I'll leave it there. So the important thing, how to plan for your retrofit. The usual complications on a retrofit. This picture on the right hand side is something that I saw in a corner shop when I was working on Ernley Close, and I just thought it showed a brilliant lack of forward planning. So yeah, not thinking ahead. If you're not thinking about things in a whole house way, you risk doing work to do it again. To go back to the point that I made earlier on, if you get an air source heat pump before you have put the increased ventilator, the increased air tightness, the increased insulation into your house, you are going to end up with an oversized system, which will cost you more to buy in the first place. A loose grasp of the aims is surprisingly common to speak to people who want, say, a ground source heat pump, an air source heat pump, solar PV, but haven't considered that improving the fabric of their house might achieve the same, well, not only would achieve the same aims, it would do it in a much lower carbon way. Lack of communication, clarity from the architect, the builder, the householder, at every stage in it. Without clear communication, it's very simple for people to go off in different directions, think that they're all doing the same thing, and you end up with something which is quite far away from the initial plan. The scope and the budget being left unclear. To go back to the people powered thing, I like to find out what the realistic budget for a householder is, not because that's going to be shared with an architect or shared with a builder. It's so that if we're coming up or helping to come up with a whole house plan, we can do it in a realistic way and make sure that that budget isn't overstepped. I've worked on jobs in the past where the scope has appeared quite clear, the budget has been quite clear, and then we arrived on the site and said, actually, we've been reconsidering this, and the budget went absolutely through the roof. And they said, well, you told us that this was going to be £30,000, and we said, yes, but you've added £5,000 worth of work onto it. Getting that scope, getting that budget, getting your plan worked out at the very first instance is really important. Don't change plans partway through. Changing plans partway through in retrofit when you're thinking about building a solid, well-constructed thermal envelope with no minimal bypass, minimal leaks. If you change your plans, you risk impacting on that. Minimal or non-existent induction and toolbox stocks for the builders. I don't think that it's necessary for builders to have had direct retrofit experience. It's important that they are skilled builders, and it's important that they are helped through that process and that they understand the brief, they understand what's intended, and that they are then supported in doing that. I can't stress enough how important it is to help the builders through the process. Again, the lack of joined up thinking. To go back to the window situation, if you have triple glazed windows fitted, size to the opening, and then decide that you want external wall insulation, the junction to those windows is going to be really tricky to work out and will never be as efficient as it would be if the windows and the external wall insulation were fitted together. It's important to think about the interplay between all the different elements within the retrofit works that you're planning. So, how to plan for your retrofit? What do you need to think about when you want to improve the fabric performance? As I said earlier, the existing condition is an important start point. Is it better to spend money improving the general state of your house? So the pointing, if you've got a leaking gutter, which is making your wall wet, if you've only got a small budget, is it more important to do the pointing and the gutters than to do something additionally to the insulation, say underfloor insulation or loft insulation? I would very definitely argue that it's more important to get the fabric of the building into a good state of repair before you think about improving the energy efficiency or adding any different technologies. And what is your realistic budget? You've got to remember all improvements are worthwhile. Talking about a whole house methodology doesn't mean that you've got to do your whole house or it's worthless. That's not the case. Every little improvement that you can do to the fabric, to the insulation of your house is really worthwhile. A small budget doesn't mean that you shouldn't bother going ahead. A small budget means that you've got to think about where that money can be most efficiently used. So yeah, in thinking about where that budget can be used most effectively, again, there is no point in changing to an air source heat pump if your house is uninsulated and drafty. Even for small pushes of work, it's worth making sure that the design is correct. As I've put, the money spent on design and planning is never money wasted. For example, if you are thinking about insulating, if one room of your house is cold, it might make sense that internal wall insulation is the way to make that room warmer. But if you then move on to doing more work to your house, it might involve external wall insulation, in which case the internal wall insulation that's been fitted is redundant. That money could have been spent on something which would have been more worthwhile and can be retained when future works are being done. Sorry, my computer's frozen. Yes, how to plan for your air source heat pump. In some cases, it might be that budget constraints mean that improving the fabric leaves no budget for the air source heat pump at this stage. Not fitting an air source heat pump as part of the initial tranche of retrofit works doesn't mean that you can't have an air source heat pump. It means that you are preparing your house for that. One example of where this might be more the case is if the boiler is relatively new, relatively efficient, the fabric improvement is potentially a better use of the budget than buying the air source heat pump at that time. If you've got a well-functioning boiler, if you improve the fabric of your house, then you will still have lower energy bills and lower carbon emissions in the meantime while the boiler is still functioning. This is the obligatory slide that always gets used when talking about retrofit, the good, cheap, fast. Sure, we've all seen it in the cheap work that's good is always slow, fast work that's good is expensive, cheap and fast is low quality, and finding that middle ground is just not possible. When you're thinking about the work, you've got to think about the impact that it is going to have on you as a householder. Changing your heating system, changing it in winter might not be the best idea. It's just, again, as I say, a consideration to bear in mind. So the summary, remember this, it's not a mistake to put that up a second time. It's really important to remember the good, cheap, fast circles. Don't rush into doing the work. Think through every stage. Don't race to get things completed. Don't race to get things planned. Really be measured in thinking about every stage. Clarity in design. Any exploratory work that can be done before the design process will save time and money down the line. Detailed drawings from an architect are important, particularly to go back to underfloor insulation. That's not something to just undertake yourself. Even if you look on quite reputable green building forums, you will find 10 different people saying 10 different things about how they've done their floor and how it worked. More drawings are better than overcomplicated drawings. So make sure if you're getting a design to break down that work into its individual components, not have a really cluttered drawing. At every stage, make sure that the scope is clear. Make sure that the scope hasn't altered. And if it has altered, make sure that there's a good reason for that having happened. Effective sequencing, to go back to what we're saying about external wall insulation and windows, It's important to think about the interplay between every element that you're introducing to the house, making sure that work doesn't have to be removed, making sure that if you've got multiple builders on site at the same time, that they're not all going to be getting in each other's way, and equally as importantly, or more importantly, your way. Clear communication. So this is the final point on it. This was a plasterer I worked with who went down a little hole that we found at the side of a chimney breast. Absolutely howling gale of air coming through it, and Robin just went, right, it's all right, I'll go down there and I'll fix it up. He had no space to work. We had to feed him onto his trowel. He couldn't have the bucket down there with him. And what that square there is the space that he was working in. And I thought, wouldn't it be nice to have a picture of his face to show people for, in reward for all of his hard work? So I sent him this message. Admittedly, probably shouldn't have put the kiss on, but that's the kind of friendship that we've got. With no question, that's the response that he sent me. I wanted to use this for a presentation for the AECB, and this was the picture that I got back off him. So that's because I didn't clearly communicate with him. Have you got a picture that I can use for a presentation? So yeah, always remember clear communication at all times. Right. If you are interested in finding out more about the PPR, People Powered Retrofit Services, or if you're not a member of Carbon Co-op, here's some information for joining us. If you're interested in a My Home Energy Planner, which is an assessment for thinking about things in a whole house way, there is the link to the website for finding that. And if you want to inquire about PPR or want to find out about the services that we can offer, then our email addresses are here. So there is Lewis, who is our retrofit advisor, myself, and also Jonathan Atkinson, who I'm not sure if the slide, there we go. His name is Jonathan at Carbon Co-op. Email any of us and we will be happy to talk further with you. Right, thank you very much for listening.
Brilliant, thanks, Liam.
That was excellent, thank you, Liam. It's that time when question and answers can happen, that exciting moment. So I know Florence has been addressing some questions in the chat box and also the Q&A. Would it be worth reading those through as well out loud? Would you like to recap on those?
So Tony asked what competencies you needed to install an air source heat pump. And we agreed that a split unit you wouldn't be able to because that's got refrigerant pipe work. But if you listen to Tristan's presentation at the last course, and you can go back and listen to it if you want, he did his own because it was a monoblock unit, so you're only dealing with water pipe work, and then the rest I think you can also do yourself. And then he also asked if when applying internal wall insulation, some of the wiring on the sockets isn't always long enough to extend to the new socket. And I think Dave answered that for him, and said you can use Wago connectors, the genuine product though, although rewiring is always best. So that was that. Eleanor asked whether the Energy Saving Trust was a good way of finding qualified contractors. Liam, do you have an answer on that? I didn't think that was a...
I don't think that's their remit. And also, no. Does the Energy Saving Trust still exist?
I thought it was discontinued.
Yeah, I thought so too. Yeah.
Are there other similar organisations? Well, so the MCS website is where you'll find the heat pump installers that you can claim RHI on, but that's no guarantee of anything, obviously. And then the new Green Homes grant scheme is trying to go through the Trustmark accreditation process, but that seems to be already causing headaches. Is there anywhere else, Liam, that you think people could go to? I personally would try and stick to word of mouth if you can, personal recommendations.
Yeah, if you've found a decent builder, but good builders only ever really work with other good builders. So if you've got a good plasterer, the chances are that they've got a route through to a good electrician, a good plumber, a good whatever it is that you're after.
Yeah.
We can also, on People Powered Retrofit, we can help with advice and procurement of builders and training if that is something that you would be interested in as well.
There's a question for you, Liam, in the Q&A.
Oh, okay.
You can see it.
I'm just clicking on it now.
Yeah.
SLC pumps work well with solar panels. In that specific context, I meant PV. Although I can't see why they wouldn't work with passive solar water heating panels. Can you, Florence?
No, you can use both. In fact, that's what my dad has on the small bungalow. He's got solar thermal panels into a large hot water cylinder, and the air source heat pump is connected to it as well. Yeah, it means you can switch off your air source heat pump in the summer because all your hot water is pretty much done by the solar panels. Certainly over here. The other thing I was going to mention about the installation here in the stone house. My dad switched without doing any insulation work, but he is between two other houses and he's got quite a lot of thermal mass, and he also has an open fire. But the main reason he switched was because he was on an oil boiler, and he's managed to halve his energy bills by going with an air source heat pump.
When I said there's not much point in fitting an air source heat pump in an uninsulated house, I forgot the existence of oil boilers. In which case, yes, very worth it.
Yes. And actually, if you heard the Tipperary webinar, a lot of the Irish experience is switching from oil. That's why it definitely makes sense. Now, Phoebe says she's an early adopter, and she's happy to share difficulties and mistakes. Phoebe, would you like me? I think I can allow you to talk. Shall I do that, Polly? Is that all right?
Absolutely, no problem. Go for it. It's much more amenable.
Phoebe, I think I've unmuted you.
All right. Hello.
Hi, Phoebe.
Hello. Right. Well, I'm just saying problems happen.
Yes.
And we need to learn from them. It's how you put them right. Hopefully the builders can deal with some of them, but I don't have total confidence that they'll deal with all of them. So, I'm afraid we need retrofits of retrofit, I think, because, the training, the competence isn't there yet.
No, that's right.
Few builders, sadly.
Yeah. And I think what Liam was saying, that if you get someone local, they've got, they've not really got anywhere to hide, and their business would go down if word of mouth was that they didn't come back and fix things. And that's definitely what's happened with my dad here, that the plumber didn't know anything about heat pumps, And in fact, I think early on he switched the flow and returns, so it definitely didn't work. And then I was here in December and it was tripping out, and I looked at the size of the circuit breaker and it wasn't big enough. So, you know, there are definitely lots of teething issues, but they, you know, he kept coming back to fix things. And if you've got that kind of relationship with your plumber, then that's definitely the way to go.
Yeah, they just need to understand new technology better.
Yeah, yeah.
I mean, I would say that some of that does also come down to the design process. I mean, I'm not going to blindly defend builders, but, you know, certain things roll downhill and it always ends up being the builder who gets blamed, when it's not necessary. It's not necessarily them who've made the mistake.
No, that's definitely true. It's quite hard to certainly if you're going for the renewable heat incentive, to present the installer with a design, though, because they have some strict parameters
Yes.
that they work with. So, but there's, yeah, I mean, I have designed these things, and I could size them and present the installer with a design, but we might have a few arguments along the way. That's the only thing.
Yeah, well, I mean, with what we're saying about where I live now, for RHI, it was designed by the installer, and they, seemingly didn't do a great job of doing the design. I think if that design had been done by a specialist, then I think we would have ended up with the correct bore of pipes.
Yeah.
For example.
Yeah, exactly. Anne says, I don't want an MVHR system. Is there an alternative which is simple, cheaper, and doesn't take up so much space? So MVHR allows you to recover heat, so you're not just drawing in cold air. You can have localized heat recovery fans, so you could have one per wet room, for example, but they are quite large, and they're through the wall. And also it means you're only ventilating those spaces where you need the extracts. So you can also have an extract only system, but at that point, so that just means you're extracting from your kitchens and bathrooms like you would in any house at the moment. It means having trickle vents in the other spaces, and it's very much down to the user what happens to those trickle vents, so it's not quite as reliable, but yeah, so you can compromise with performance basically, but if you wanted to recover heat, then that's pretty much the only way you can. Or you could have an underventilated house. That's the other. That's the downside. Anyone else? Are there any hands raised? Oh,
Stephen's made a comment.
no. Care heat recovery works on humidistat should work well and properly. Is that air heat recovery works well on humidistat? Should work well when properly installed. So Stephen says, I was thinking of an EcoDan 8.5 kilowatt ASHP, but since last week I'm thinking of a 5 kilowatt. Are there several suppliers of ASHP 5 kilowatt? Yes, yeah, pretty much all the larger, well, you can definitely get a Dakin 5 kilowatt, and or it might be between a 4 and a 6. You might you might find you're in between, but do check your your heat load calcs, your heat calcs, because obviously Tristan and Andy have made improvements to their fabric, and they've learned how to use it so that it still meets their demand, and that might be by reducing their internal temperatures. So you will need to do a few calculations just to check that you're meeting your requirements. Heat pump question for last week's. Read an article by our Tipperary friends, and the steer was to run the pump for long periods at lower temperatures to maintain a more consistent temperature and to avoid inefficiencies of repeated cycling. Is that right? Yes, that's absolutely right. And that's why you might have a buffer tank as well, so that you can, actually that's the opposite. So your buffer tank, no, that's right. You want more water in your system, so that you're constantly having to maintain a certain temperature of that system without turning it off and on, because that's where you'll get your lowest efficiencies otherwise. Suppliers often want to overspecify ASHP in your experience. Yes, that's right, Phoebe, and some of it is because they're scared of the liabilities they have, and the RHI has some specific guidelines, and they have to base it on the EPC, for example, not what you tell them you want them to size it on, and that doesn't always match the way you want to heat your home. So I started with single room MVHR in bathroom and controlled dehumidifiers. Expensive to run, but it worked. Upgrading to whole house MVHR was a huge improvement. So that was Dave's experience of MVHR. Oh, he's only posted it to all panelists, so I'll just copy that to everyone.
Oh, actually, I think quite a few people have only posted to all panelists looking at it.
Yes. Yeah, if you want the whole of the webinar attendees to see your questions or your replies, you need to check who you're sending the question to, or your reply to in the chat. There's a little drop down, and I think it defaults to all panelists, or it depends on your own defaults.
Seems like we're running out of questions, doesn't it?
Yeah, yeah.
It looks like, yeah, if you want to add anything else, you, Liam or Florence, to any of the things you've said tonight, but I think you've reiterated really well about, you know, the pitfalls and the caveats of, you know, obviously we can have issues around installation in the retrofit context, especially if, you know, you're doing things in the wrong order. But obviously fabric first is the thing that's been emphasized, I think, and it's not to put people off, it's just to give, yeah, kind of keep that emphasis there, and that you can still, you know, reduce your emissions and retain a lot more heat that way. But air source heat pumps are great, but be very wary of getting them when you haven't got that heat retention in place through, you know, even a little bit of retrofitting can help with that, like Liam has said as well. And yeah, I think if people are happy to, you can send more questions if you have them, or you get questions from other householders that you know who might be on a retrofit journey, and sort of forward them to us. Is everyone happy for the email addresses to be shared?
Yes, absolutely.
Yeah, Liam's already just read my mind and shared his.
Yeah.
So that would be great. We'd love to hear from you. I did actually, for some people who got it, I definitely sent round the Eventbrite link with also a questionnaire link, just asking people where they might be on the retrofit journey, and if they would like our support with that. We can actually, you know, give more info and point you at certain resources, but also, you know, arrange for you to have an energy assessment. I think Stephen's mentioned his is coming up hopefully soon. We have got a very, very busy calendar for those, haven't we, Liam, I think?
Yes, quite busy.
Yeah.
There are more people. We are going to have more assessors as well, so the capacity is improving all the time. But yeah, getting the backlog of COVID out of the way.
Sad but true.
Yeah,
It's a good problem to have in a way,
Yeah.
not COVID, but the amount of people wanting energy assessments. I'm very much not of the belief that the pandemic is a good problem.
I'm going to cut this now.
Yes,
Make it sound that way.
Please don't. No media editing skills, please.
Yeah.
But yeah, no, it's been really nice to have everyone on this call, and apologies for anyone that for any reason didn't get the link. And I will, just in case, I will send next week's link out early as requested by Phoebe, along with the questionnaire link again, and the emails for Florence and Liam, just in case. So yeah, hopefully that helps everybody. And thank you for the virtual clapping from Stephen.
I think there's just one last question on the Q&A.
Oh, another one, go for it.
What are your thoughts on floor insulation, insulating existing suspended wood floor or replacing with an insulated concrete floor? Liam, have you got?
I would always prefer replacing with an insulated concrete floor. It's not possible in all situations, and so there is a time and a place for insulating an existing suspended floor, but if you can, I would go for an insulated concrete slab. There's a lot less possible problem with trapping damp, causing moisture and humidity to rot the joists. It's not to say that a well-designed insulated timber suspended floor will perform well, but another thing that you can get with an insulated concrete slab, which is so hot right now, is underfloor heating. So, what do you think, Florence?
We see what you did there.
So hot right now.
Well, yes. I don't know, to be honest. But I guess if you're interested in your embodied carbon footprint, you might want to do what you can to insulate an existing floor. But there will be pros and cons of each, and definitely get an expert to design that insulation for you. I have that actual dilemma to think about myself, so watch this space. Stephen's asked what next week's will be about. I don't think it is next week, is it, Polly? It's in 2 weeks' time.
Yes, it's going to be on September the 2nd.
Yes.
Yeah.
So that's
this one. I think we were going to run case studies, and
yes,
I think have a bit more of a breakout session and help people address specific case scenarios.
But I was going to go through the technical bits of heat pumps.
Yeah,
So
and the technical bits. Yeah.
Basics about how heat pumps work. And I just thought I should run those through with you, so that you understand how the actual process works. And yeah, that's the idea. Now that you've got an idea of what the outcomes are, I'll take you back to the theory. If that's okay.
I think that makes good sense. Good approach. I am biased, but hopefully everyone else the people that have been attending throughout the series will be able to make it next week. I'm going to send the link out a couple of times to avoid any confusion, and also give people the opportunity as well, if they still want to sign up. There'll be sort of always somebody that signs up at the 11th hour, so everyone make sure they get the link as well. But yeah, it's been fantastic. Thank you to both yourself, Florence, and you, Liam, for the really interesting presentation. I'm learning a lot. I wish I was in the position to retrofit my house, but I'm not yet. But someday the dream will be reality. But yeah, many thanks to all on the call as well who've made it on this very rainy night here in Yorkshire. I have no idea if it's rainy everywhere else. I'm gonna hope it is, so I don't feel left out. Sorry.
No, I'm worried that I'm going to grow gills the way it's been the last couple of days.
Exactly, British summertime at its absolute best. But anyway, it's been wonderful to have everyone on the call, and thanks to everyone. I'm going to press stop recording now.
Yeah.
Unless anyone's got any last burning questions. Raining in Macclesfield, thank you, Stephen. I feel so much better now. Great. All right. I'm going to make sure this sound